we're looking at a theorem now. The statement goes like this. The length of tangents drawn from an external point to a circle are equal. So I would like you guys to pause. I'll give you a clue. So we have a point P. So from that, I will draw tangents. So maximum I can draw 2 tangents to a circle. So the thing is, now I would like you guys to pause and think about what is that exactly we have to prove. Right? So I'll give you some more time. During that time, I'll describe the diagram. Consider a circle with center O. Let P be an external point then what else? PA and PB are 2 tangent to the circle. Okay, so now I'll be writing what is that we have to prove. So I hope you guys have got what is that we have to prove. We have to prove that PA is equal to PB. So next is your construction. Right, this is what we have to prove. The length of the tangents, that is PA and PB, from an external point to the circle are equal. So that's what we have to prove. So how will we prove it? For that, I'll give you next set of clues. Join OA, OB, and OP. So I'm joining that. So are you guys able to figure out what exactly we have to prove? No, not it. So the proof goes like this. Next thing is how is that we have to prove? What we have to prove, we already discussed. How is that we have to prove? Did you guys figure out? The next clue is consider triangle OAP and OPP. Now, any idea? OAP is equal to angle OBP, which is equal to 90 degree. Reason, radius, and tangents are perpendicular to each other. Okay, so this to 90. Then OA is equal to OB because they are radius. Now, did you guys get what is that we are trying to do? Still no? OP is common. I'm sure most of you got it. Yes, we are trying to prove that triangle OAP is congruent to triangle OBP. Once we prove these two triangles are congruent, thus PA will be equal to PB. That's it. So we proved that a right angle and a hypotenuse and one side are equal. Therefore, triangle OAP is congruent to triangle OBP by RHS congruency. Right angle, hypotenuse, and side congruency. Therefore, AP is equal to BP. Hence, proved. Right? This is by CP, CT, corresponding parts of corresponding triangle. Sorry, congruent triangle, corresponding parts of congruent triangle. Quite simple theorem, but this theorem is used on a lot of problems. So understand it. It's very simple. But when it comes to a lot of complicated diagram, people get confused. You need not be. I'll show you ways to handle it. So please don't get confused. It's a very simple theorem.